And we are live. Welcome, everybody. This is Giuseppe from the IoTeX team, aka the Deep in Jesus. I'm here today with Simone and Marcus from Edge and Node, and we have, I think, a pretty cool, some pretty cool content. Um, and I'm gonna get my friends up on stage with me right now. There's been a lot of talk. We posted a lot about this, and we essentially going to show you guys how to index some of the like IOID contracts in this live stream. Why we're doing that, we've talked about it before, but I'll let maybe Simone chime in and talk about this when we describe the scope of the live stream. What I wanted to do now is a couple of things. First of all, welcome Marcus and welcome Simone. It's nice to have
Hello,
you
hello.
again.
Hey
Hello.
guys. Hello, hello.
And Marcus, we promised this a couple of months ago when we did the live stream in your Discord, and we finally made it happen.
Yeah.
Last time we spoke, we were also hinting about a possible integration with the graph and IoTeX, and
Yep.
it's finally happened. So now both mainnet and testnet can be indexed through the graph. We were chatting in the green room about it. Marcos, if you want to maybe share a little bit more about this, lots of exciting stuff. Feel free.
Yeah. Well, thanks for having me. Good to see you, and good to see you, Simone. I'm working really hard to always talk about how cool subgraphs are, and no matter the situation, I think this is just an amazing situation to share with the IoTeX community what has been unlocked for mainnet and testnet smart contracts. So yeah, IoTeX is now available to be indexed by subgraphs that are on the graph. And what that means is all of the event data from the very beginning of your smart contracts deployment all the way to this very second is able to be indexed into a decentralized database. And then from that database, you have an exposed API key, API endpoint, of which you can use an API key to go ahead and query and go ahead and get all that data and create some amazing use cases from that data. What do you want to do? Do you want to do analytics dashboards? Do you want to do compute? Do you want to go ahead and find and compare data from different timestamps? You're all able to do that and really see in depth what is going on with your smart contract at any given time and create some amazing analytics from that.
Sweet. And Marcus, in the green room, we were chatting like, now we have achieved this, but there could be more coming, right? So what would be
Yes.
like an enhancement maybe of this integration?
Yeah, so any smart contract developer on here knows about events. And if you don't know about events, briefly, events are essentially logs that are stored on chain for any significant moments in a smart contract. And a subgraph is highly specialized at indexing these events. And from those events, we can get tons of data, which is great. However, and let's just back up a little bit, that solves so many use cases already. We don't have to get anything more. Events are already super powerful if you know how to use them well and time them well and have them integrated in your smart contract well. So that's already a huge win. There are other use cases where developers will want more than events. They'll want internal transactions. They'll even want mempool data. They'll want all block data. And that is also available with another technology built from another core development team in the graph. The team is called Streaming Fast, and the technology is called substreams. So if IoTeX developers would like full block data and analyzing basically the entire chain, not just events, but anything that has ever happened on the chain, there's an integration process that we potentially could go into. It's the technology we would have to integrate is called Firehose, and we would attach Firehose to IoTeX mainnet and testnet, and from there the substream could plug into Firehose and essentially get raw blockchain data streaming in parallel, which is pretty dang cool. So if that's something you guys want, let your development team know, and we will be happy to help you guys plug in Firehose and get full block data.
Yeah, I love that every time it seems that the trend is every time we're like live and we discuss it, then we hint at like the next thing coming up for IoTeX and the graph, which is pretty cool. Yeah, that would be awesome. So for all developers out there, if that's something that, for example, you would want, just like feel free to reach out to us, and then we'll see if we can make it happen. Which brings me to maybe some like quick, not housekeeping, but like if you want to keep in touch, for example, with Marcus and what he's been building and like what his team is releasing. Marcus, what would be the best way to do that?
I would say the best way to have a singular news feed for any core development team in the Graph ecosystem would be to go to Twitter. It's Graph Devs. It's a relatively new Twitter account that every core development team in the Graph ecosystem has access to, and they can share any news, any features, any new tutorials. That's the place to go. That would be Graph Devs. And then also following me on Twitter, of course, Marcus, Marcus_Rein, REIN, and then there's an underscore at the back too. So Marcus_Rein_. And I'll drop those links in the chat, so that's just easy for you.
Yeah, and then exactly, then I can highlight them.
Yeah, let's go ahead and do that real quick. All right, that is my Twitter, and then let's also get the Graph Devs.
Okay, let's do this, and then I'm sure we're all itching to show you guys what we've been preparing. So
there we go.
We'll get that rolling.
And there we go.
So this is Marcus, and let's see, we have the Graph Devs. One sec. Okay, cool. And this is the Graph Devs. And in the same way, on our end, if you want to then stay up to date with all the tech stuff and development stuff that's going on IoTeX, which is always a lot, feel free to follow IoTeX_dev on X. You're already on our YouTube if you're watching on YouTube, so you don't have to do much more there. And then I will drop maybe the links for my personal account and Simone's personal account as well. And we try to always educate or keep our community up to date with what's going on. Sweet. I think we can start jumping right into it. So we call this live stream upgrading your DePINs. And I thought it would be interesting to call it that way because if you think about it, once you build your DePIN project, let's say you're building on IoTeX and you're using IoTeX infrastructure, then since a lot of this infrastructure is anchored on the IoTeX layer 1 and it's anchored on chain, you can basically then use tools such as Marcus was saying with the graph and start indexing all these smart contracts to basically gather very interesting insights about your DePIN applications. So in the specifics today, and I'll let Simone jump in a sec, we're going to index some of the IoID contracts, and this is going to allow us to basically have eyes on, for example, how many devices a project have, what kind of revenue could be generating, how many individual wallets we have in a DePIN projects, and so forth and so on. And we've talked about it before, but there is a lot of talk about DePIN verifiability, and I think having an identity management on chain for this purpose, and also leveraging tools like the graph, it becomes very, very powerful. Hence the upgrading your DePINs. But I would like Simone to first. Hi, Simone. How you doing?
Hey guys, good. Thank you.
Hello.
Sweet. Yeah, we've done a few of these, so sometimes I just keep on talking. I don't even think that I should maybe introduce.
No worries. We're here for the next.
Exactly. So yeah, I think let's get right to it. I think Simone, you had some slides, some content, basically explaining in a little bit of depth what we are doing, and after that we pass the ball to Marcus to basically go through how to index these contracts and gather some of these insights, and then maybe if we get some comments in the feed with some questions and we get to them, then we'll be happy to answer them. So for everybody that's watching, feel free to drop your comments, And if you have any questions, then we can answer them live. If we don't get to them, maybe we get to do it offline. I'll share with you, Marcus, later on, and Simone. Cool. Simone, all yours.
Excellent. I'm sharing my screen. If you can bring it up. Excellent. So yeah, basically I'm going to introduce at a very high level, one of the pieces of the IoTeX infrastructure that is tailored for DePIN applications. And specifically today, I'm going to introduce the management of the identity lifecycle in a DePIN project in a decentralized fashion. And that's because after Marcus will show us how to utilize the graph to index exactly the contracts that are part of the IOID, which is the IoTeX framework for identities management. So fundamentally, in a truly decentralized DePIN project, the first critical step is how you actually decentralize the management of device identities, device ownership, utilizing the blockchain. So in IoTeX, each device of a DePIN project, whether if it's a Wi-Fi access point, a weather station, or a car, is registered on the IoTeX blockchain through IOID, which is the IoTeX module dedicated to manage the identity lifecycle in a DePIN project, both utilizing on-chain components and off-chain components. And IOID basically allows DePIN projects to securely authenticate valid devices that belong to their project, and device owners to register their devices and start earning rewards from the DePIN project. And once a user registers their device, an IOID is minted on the IoTeX blockchain. And the device at that point can start authenticating itself with a decentralized identifier, what is also called DID, which is bound to its on-chain IOID identity and to the owner. So all the messages typically sent by a DePIN device in IoTeX are processed using WebStream, which is another IoTeX module tailored for DePIN project for verifiable off-chain computing. And WebStream can process thousands of messages from devices in near real time, calculating proof of physical work for each device. And these results, along with the ZK proof, are basically sent on-chain to the DePIN application. And on the IoTeX blockchain, the DePIN DApp instantly verifies a single proof and automatically triggers fair rewards to thousands of device owners based on the actual performance of their devices in the physical world. And the entire process is fully decentralized, it's verifiable on-chain, and it's designed for basically bootstrapping a fair and transparent infrastructure for a DePIN project. So basically, as I mentioned, IOID is also composed of on-chain smart contracts that manage the identity registration, the ownership assignment, the identity of the device, of the DePIN project itself, commissioning and decommissioning of devices, and so on and so forth. So if you are actually interested in the source code of IOID, it's available on our GitHub repository, /IoTeX project IOID contracts repository. And today, Marcus is going to show us how to index the let me find it, IOID registry contract, which is one of the more interesting contracts that contain some quite interesting events to index, for example, when a device is registered, and so on and so forth. So I'm actually handing over to Marcus for getting us into the details of the indexing.
Amazing. Okay. So thank you for that, and good handoff. Yeah, good handoff with this smart contract. So what I'll do is just a real quick overview of the file structure of a subgraph, and we'll spin one up and we'll just let that go and just show what that demo is like on how to do that. And then we'll switch over to a subgraph that's already indexed and already ready to go. And just so we could have two learning environments, we could see how to spin up a subgraph from 0, and then from there see one that's deployed and indexed, and we have fresh data to go ahead and take a look at. Does that sound good, guys?
Great.
Cool. Awesome. So let's get to it. I'm going to share my screen. Okay. Can everyone see my screen? Yes?
Yes.
Yes. Okay.
Yeah.
Cool. Amazing. So this is the smart contract that Simone gave me. It's the IOID registry, and said this was an interesting smart contract. And this is the first step as a subgraph developer, which hopefully everyone in here would like to become with their smart contracts. The goal is to say, all right, well, let's take a look at the smart contract and then look at the events that are in the smart contract and what we're going to be getting. So what we want to go through is not all of these imports. Let me make the screen a little bigger. It's probably pretty small for everybody. We have all of these imports that are coming in from OpenZeppelin, which are great. And what we want to look at specifically is the stuff from IOID. And we want to look at the registry. We want to see IOID registry.sol. We're going to take a look and see, all right, what are the specifically the events in here? And these are the events that we're looking at. And this is what the subgraph is going to be able to gather. And so when we're starting this development journey, we want to just first look at our location and look at the different events that we're getting. And there's more events in here, of course, but the one that we actually really want to look at is the new device. That's the cool one. Simone, Giuseppe, and we all talked about this new device one. That's the cool one. Because essentially, correct me if I'm wrong, guys, here, you guys know the smart contract better than me, but anytime there's a new device that has been added to this smart contract, this event is emitted. Is that essentially what this is doing here, just to be clear?
Yes.
Cool. All right. So we're just going to trace this event here as it goes through. And now that we know what we know that we want not only this event today, but every single new device event that has been emitted since the beginning of the smart contract, we can get to work. So let's go ahead and get to work. The first thing we want to do is, of course, understand that we are on a testnet. We can confirm that here. We're on testnet.iotex. And then also we want the actual hash right there. So those are the two things we need before we get going to the graph. And what we'll do is spin up a subgraph together. All right. So what we're going to do is we'll go to products, subgraph studio. And we're going to index this smart contract. This is the one that we're going to look at later that's already been deployed and indexing the smart contract. But right now we're going to do it live. Call this IoTeX live demo. And we're going to create a subgraph. And then from here, we're given a dashboard. This is our private dashboard. And from here, we can begin naming our subgraph with this private dashboard. When we deploy our subgraph into this private dashboard, we will be able to have an API endpoint where we can go ahead and send our queries and play around. Right now, of course, as a draft, we can't do that. Just know that this is where we get to play around, and it's private. We don't have to go ahead and make this public to the world just yet because we are developers and we want to develop as such in a private state. So what we want to do is go to our CLI and then do graph init. Of course, you will need to install the CLI first. So if you haven't installed the CLI, do that. We'll graph init, and we have my iTerm here. And then it will ask which protocol that we would like to go through. Because IoTeX is EVM compatible, we do Ethereum. Go do the defaults, and then we're going to go ahead and find IoTeX testnet. There it is, IoTeX testnet. So now that contract address that we had before, we're going to go ahead and grab that. There it is. And then from there, we will go back and drop it in. Now, depending on the block scout, sometimes the ABI cannot be found, which is totally okay. Now, sometimes it can't be found, sometimes it can be found. Don't worry about it too much, because if you have a verified smart contract, what you can do is just grab it manually and plug it into the CLI. So what you'll do is grab the CLIs, grab the ABI. We will go ahead and say we will not retry this. That's okay. And then also sometimes it can't fetch the start block. You can keep on retrying. Sometimes Block Scout or the Etherscan can't find it. That's okay. We'll just put it in there. We will not find it there. We have to actually supply the ABI file itself. And so we'll just do, what we want to do is go ahead and just do a code in here. And we'll create a new JSON. We'll call this abi.json. A little bit of manual work here, but it's okay. It's pretty simple. Now we have the abi.json in the same folder, and we just go ahead and go back here, and we say abi.json, and there it is. So now the start block, we go ahead and go to the start block of where the smart contract was initially deployed. And so we can go into transactions, only 9 in this one, that's okay. There's a reason for that. This was done 2 months ago. And here's the block height. We don't want to go ahead and do the block height from 0 because that would basically take way longer to index. We want just the block height of where the smart contract was deployed up until today. So that's going to make our subgraph index much faster. Contract name, you can name it whatever you like. Cool thing about subgraphs is you could actually index many smart contracts on the same chain with the same subgraph. So let's say you have 3 smart contracts, 10 smart contracts all on testnet here, on IoTeX testnet. You could totally do that. So it's good to have separate contract names, but just because we're just going to do one, we'll just name it contract, that's fine. And this is where the power of subgraphs come in. Index contract events as entities. So this is where essentially you're taking your smart contract events from the beginning of every single event that has ever been emitted and converting those into a entity and converting those all into entities in a database that is in the subgraph. And so that's the cool thing that occurs right there. It automatically spins this up locally, and we'll go from there and deploy our subgraph. Any questions so far? Is this all making sense? Is there anything else I should go over, guys, while this is spinning up?
No, good on our end. And yeah, I encourage everybody to just drop questions if you want here in the comments. But no questions so far, just some shout outs for the graph team and us.
Awesome. So add another contract, no, and then we want to go ahead and continue on. You can go ahead and go through these steps. I like to also go back to Studio, which will tell us essentially what we have to do as well. Authenticating is important because that will allow our computer to communicate to the Subgraph Studio, which we're in right here. I'm not going to authenticate because that exposes this key, which I don't want to do on the live stream. And I've already authenticated my computer, so that's fine. And then from there, we CD into the folder. And then from there, we can start to explore a little bit about this subgraph before we build. And then before we do code gen, which is type safety, and before we compile, which is graph build. So let's go ahead and explore the subgraph really briefly and see what it spun up. Code. And we're going to go ahead and see in the subgraph.yaml what we see here. So what we see is this new device. Remember we talked about that was the cool one? That's what we want. We want the new device. And we see the entity. We're basically, I'll make this bigger for the screen. In this subgraph.yaml, this is the most important high-level file in the subgraph. It basically tells us the entire story from a high level what the subgraph is doing. It tells us the address, what it's getting, tells us the start block of where the subgraph is starting indexing. It also tells us the entities in the database that it's going to be populating. And as we can see here, these entities have the exact same name as the events that are on chain. So we see the new device event is going to be coming from the chain. It's going to be triggering this handler, which the subgraphs locally has already spun up automatically. And it's going to go ahead and go from the event into the handler. And then from there, it will populate this database entity right there. So that's basically it. And so how do we go ahead and keep on tracing this a little bit deeper? Let's go to the next file. What is this handler about? We talked about handlers. It's automatically here, handle new device. There it is. So we have it right there. It's automatically been spun up. We don't have to do anything. It's there. So we're really quickly just going to go through this about this handle new device handler. If a event is emitted that is of the type the new device event that is generated by the CLI for us, we essentially create an entity in the database. We give it an ID, and the ID is automatically created right there. We don't have to do anything. And this ID is going to be allowing us to say, hey, this exact entity in the history of all different events that has ever been emitted will have the specific data. It's going to have the specific data that is going to be named the exact same fields that were actually in the event itself. So we have the event params, the device name, goes into the database. This owner goes into the database. This hash goes into the database, and the URI all goes in the database. And then every single entity that is ever created also gets some block information. We have the block number, block timestamp, and then also the transaction hash. Whatever triggered this event to occur, we'll know the exact transaction in every single database entry, which is pretty cool. And then we just save it to the database. So what does our database look like? Let's go ahead and go to our schema.graphql. These are the three most important files in every single subgraph. You have the high level, you have the handlers, and then finally it passes through the handlers into the database. And then let's go ahead and see, bam, there's our new device. So we have the ID of this single entity in the database, and then every single new entity that comes in here will have a different ID. And so we can have lots and lots of those entities lots and lots of those fields being populated. And then so here we have the device, we have the owner, we have the hash, we have the URI, we have the block number, block timestamp, everything that we just went over in the handler itself. So any questions about this flow, guys? Should I go over anything again, or is this all making sense?
I'm good.
This is good.
Again, yeah.
Yeah, all makes great sense, actually. Excellent.
Lovely. Cool. These are the
Marcus
three files.
Is good.
I try to be as concise as possible. I know developers have very limited spare time, so I try to compact it.
I can maybe
anyways.
Later on, I will add a little bit more details on the IOID side. When exactly this event is generated, what are those properties that you are indexing?
Sure, you bet, you bet. Yeah, so we can go into the event signature is right here, so we can go into what all these things are from the IOID side, and dive into the smart contract and have fun there. Let's go ahead and deploy this thing. So how do we do that? We just simply come back here, graph code gen graph build, and that's going to do the type safety and build it. And then because this is a recent integration, we were having a little bit of errors just literally a few days ago, and hopefully this integration is now clean. We will see the live demo gods if they behave today. So we just give it a version after copy pasting, and we go ahead and deploy to the studio, and now we are live. So yay, we have the deployment right here, and we already have a endpoint that can be used for development. Notice it starts with API. This actually goes to an API managed by some of the core devs at the graph, just for development purposes. This is not decentralized just yet, but that's okay because we're just developing on it. And we should start to see a 0.01. There it is. So we're getting the indexing progress, 85%, current block, final block. It's already going. Subgraph go burr, and we have it which is pretty dang cool. So from here, we have a playground, and we can start sending queries to this data. Even though we're not getting, we're not at chain head, we haven't fully indexed, we can already start sending queries. Typically, after just deploying, it takes 3 to 5 minutes for the database to really get organized, so it's normal to not see any data here just yet. But we can start to go into all of the different little events. And remember that new devices event that we thought was pretty cool? That's the one that we want to start having fun with. So just because I knew we would be having a live demo today, I already created a subgraph to index this exact same smart contract, and I extended it a little bit to create some cooler stuff. And so let's go into that really quickly here. This is the IoTeX live demo, and this is the demo subgraph. Here it is. This is the same thing. We have the new device. We have the subgraph.yaml. We also have the handler right here, and we have the database. The only change that I made with this is I created a new entity in the database because I wanted to say, hey, who are these owners and how many devices do they own? And I just want to know that, and that'd be very helpful. So what I did was I created a place in the database. I like to work database first. Some people like to work in the handler first. I like to think, okay, what do I want as my final product? And this is it. I want to know the owner, and the ID is going to be the owner's, as I recall, that was simply their address. And I want to know the devices that they have. And it's going to be an array of all the new devices they have. And how did I do that? I went here. So pretty simple. I said, here's the, I went into the handle new device. Anytime there's an event that has a new device, that a new device is added in the event, I'm going to run through this. The owner ID is going to be the owner. That's the actual hash of their address. And then from there, we go ahead and simply save it as a new owner. That's all we're doing. If it doesn't exist, if owner equals null, then we create something new in the database. Everything else is the same. So this has basically done all the heavy lifting right here. Devices is a new entity, a new field, and we're getting these new devices here. And the new device already is there. This is created from add new device. So from there, a little bit of dancing around there, but I'll just go ahead and show you. We have, with this query, I said first 1,000 owners, and I want to know the owner's ID, and I want to know the devices they own. And let's say, if they own 100 devices, let's check that out. We can send the query. It's going to go ahead and look. And now I'll make this bigger. And now I can say, hey, cool. I know this owner right here. That's the ID. And it has these devices, and this device has the entity. This is the entity's ID, but this is the actual device ID, and this is the device ID, and this is the device. So this one person right here, or this one wallet, I should say, has these 3 different devices. So that's a real quick use case of the power of subgraphs, the limited amount of code you actually have to put in here to actually start creating relationships. We have this array, and you can start assessing your smart contracts and what the heck is going on pretty quickly. And it doesn't take a heck of a lot of work. Of course, I had to do one more thing in here just to say I was creating an owner entity in the database, and that's the last thing I had to do. But essentially, that was it. So I'm going to stop there and see if there's any questions or anything else I should go over again that wasn't fully clear before handing it back off. And I mean, I could talk more about subgraphs, but I think this is a good time for me to take a break.
Yeah, no, I think it's actually good. And again, amazing handoff, because I wanted to ask Simone a question now based on this, right? So, for example, with the, let's say, a little bit cooler modification that Marcus made, right? And now we can know how many owners in a certain DePIN project have how many devices, right? And that's a good, I think, segue to talk a little bit about, verifiability in DePIN. There is a lot of talk about verifiability in DePIN. A lot of, projects work on like DePIN verification. What is the difference, and how important is it for, a DePIN project to maybe have, in this case, like an identity system that can be verifiable on chain, so let's maybe talk a little bit about that. And
yeah, actually that could be like a long discussion, so I'll make it short just to provide some quick information about this topic, and then anyone can maybe do their research. But basically, a DePIN project is quite different from let's say DeFi project, right? DeFi project is mostly an on-chain component with several smart contracts, maybe utilizing some off-chain oracle for price feeds, but that's it. But the DePIN project is actually coming from IoT systems, which are pretty complex, that then somehow are modified to integrate Web3 concepts. However, IoT systems historically are basically cloud applications, and currently the whole logic of these DePIN projects is very similar to IoT applications, Web2 applications. So the whole logic is usually inside the cloud, and typically you only have some tokens on a blockchain, which somehow acts as a reward, a crypto assets to reward or to incentivize the infrastructure. However, this is definitely not verifiable. When we say verifiable DePIN, we mean a DePIN project that actually respects the Web3 principles, meaning that everyone should be able to observe on the blockchain everything, or anyway, the fundamental things of this project not only seeing like token transfers, but actually should be able to verify how these rewards have been computed. For example, how many devices and how active they are, and what's going on when a device is like added to the project, it's removed from a project, when a device, when someone wants to transfer ownership of a device. Everything should be like observable and composable if you want to call a DePIN project a Web3 project. And so to achieve these, you have to decentralize several components of what is usually in a Web2 cloud. And the most fundamental one, when you want to get started with this process of making your DePIN project verifiable, is to start managing identities that usually are stored in the cloud, right? Like your user information, the email, the smart contract for rewards and everything, it's usually in the cloud. So the first step is exactly to decentralize this identity management, lifecycle management. And IoID helps a DePIN project with a ready-made end-to-end solution to manage identities in a DePIN project. And this makes already a lot of difference in terms of verifiability, because then you have all your devices on chain. They are associated to your DePIN project identity. They are associated to the owners, and anyone can like check the, let's say, the rewards distribution, not the whole logic that's still living in the Web2 cloud, but at least they can see the activity of the devices, and they can achieve a lot of composability. For example, trading or injecting these assets into DeFi applications for example, for tokenizing the income from the DePIN project, and so on and so forth. And then the next step would be to decentralize as much as possible of your DePIN logic that's into the cloud. First step here could be decentralizing how you actually compute the proof of physical work and then associate a reward to it on chain. So you could like decentralize the data processing that somehow proves what the device has done in terms of the proof of service, let's say, or proof of utility or proof of physical work, should be decentralized. And we, for example, provide WebStream as the off-chain ZK-based verifiable computing that allows to process DePIN data and generate a proof for that proves the actual work for everyone to see how the work has been computed. And then this like index of work goes on chain, and that's where you can also decentralize the logic, where you associate a certain computation to this proof of work to generate your rewards, or to trigger whatever like financial or token economy on blockchain, and everything becomes more and more transparent for the DePIN users and partners. And then there are more steps to fully decentralize a DePIN project that also involve other infrastructures like data availability layers to actually store and leave the data available and maybe immutable. And then the hardware verification. So there is a lot more to DePIN verification. And decentralizing your logic, your identities, it's definitely one of the most important elements.
Yeah, I think identity is one of those things that is so important for Web3 to lean into, and to do it well is verifiably is.
There is a lot you can do once you just start managing the identities on chain. And that's definitely the first thing you want to do. And thanks to, for example, to your example, which by the way, I really thank you for joining us and giving like this like official tutorial, because it is going to be a great like reference for future developers to get started. And I actually looking forward to see these like new dashboards that they are going to create, like exploring DePIN projects with, I don't know, list of devices, list of users, amount of rewards, activity of devices, and I'm sure we will see amazing things being built.
Yeah, I would recommend, if any developers out there that are excited about this kind of stuff and maybe just want a little bit more guidance, is it okay if I just do a little quick screen share about some like tips that I can give for like the next steps? Because like already you're thinking of all the events that you can do. That's already really cool. What I would really recommend is start thinking, okay, if I'm going to be building these subgraphs, I need to think about the end product of a subgraph, which is, of course, the database. You want it to be organized, so it has to be organized well. I like to think in terms of database first, of like, what do I want? And this is a workshop that I've done many times before, but essentially it holds true in terms of just high-level ideas about how a database should be organized. When you create these entities in the database, this was for an NFT, but you guys might not be doing NFTs. You guys might be doing NFTs for ownership of the DePIN devices. Think of a database that has an entity of every single contract that interacts with the contract that you're focused on. Every single account that is specifically an owner's account. In subgraphs, you could identify if a hash is an EOA or if it's just a regular smart contract, and you can do that with a subgraph. There's so many cool things you can do with subgraphs. You can also, of course, look at the NFT itself. You can go into the metadata URI and actually go, if you're storing the metadata and some of it on IPFS, a subgraph can dive into IPFS as well and index that data as well. So that's pretty dang cool. And yeah, that is the metadata right there, the file data sources I was talking about. There's so many cool things you can do. And a new feature that I should add in here is what's called time series and aggregations. Essentially, you could pick X time and Y time. And I'm sorry, that feature's not live yet. We have just day, I think day, hour, I think day and hour are live right now, but it's a brand new feature where every single hour of the day or every single day itself, you could run compute inside of a subgraph. So let's say you want to look at, just keep it simple, the transaction volume for a day, and you want to summate that every single day. You can do that within the database. You don't have to do that at all within mathematics and logic, within assembly script, which can be, well, how do I do that? You literally just type in sum and then day, and then you're done. So look up time series and aggregations, and that's really, really cool too. So those are some other cool things you could do with a subgraph beyond just associating, one-to-many relationships, which is, that's cool as well, but everyone knows about that. I would dive into time series and aggregations if you really want to do compute over time very fast.
Awesome. And these features where would you redirect people to learn more about this?
I would just go to the docs. I would say thegraph.com/docs, and I'll just type in the features I talked about. There's so many features. There's so many features subgraphs can do. If you want to reach out to me, feel free to reach out and be like, can I do this? Can I do this? There's a lot of things they can do. I go to the graph/docs, and the features I talked about were time series and aggregations, as well as file data sources. That's for IPFS indexing. And also Arweave, if anyone has data on Arweave, that can also be brought in, even though it's off-chain. That's pretty cool. And I think those are the two sources I talked about. Beyond, of course, just database, conceptualizing, thinking about a database and those entities you should create in the database. And that's about all I want to say about any developers out there that want to, level up.
Sweet. So let me just share that again. So it's thegraph.com/docs. And if you feel so inclined and want to learn more about what Simone was talking about as well, I'll share the IoTeX docs too. And Simone, was there anything else that you wanted to share in terms of diving deeper into like the architecture of IoID or something you were saying earlier?
I wanted to add something, but honestly, we are almost over the time, and there's been a lot of technical stuff. I would just say, if you are interested and want to dig deeper, feel free to join our Discord. You can share the links afterwards.
Discord, actually, that's easy too. It's iotex.io/discord, by the way.
I think it's /dev Discord.
Oh, you were saying them directly to the dev. Bypass the whole other thing. Just straight to the dev.
I didn't even know there was a /Discord actually.
That's
actually,
nice.
Okay, because we have like advocates over there. So if you have questions, feel free to write there or try to reach out to us on Twitter.
Yes, and actually, let me do some of the links sharing. So our IoTeX dev is this channel here, and if
Let me
you
also
want
get the
to
link
get
for the
in,
graphs Discord too.
yeah, drop it here, Marcus.
Yeah.
And then if you guys want to have a, follow myself and Simone, I think, we try to always keep up with like cool things going on in the IoTeX ecosystem and trying to like share our insights. You can do so here. Oh, wow. I concatenated our URLs here, but
Nice.
Sweet. And
links.
Exactly. And here's Marcus, the Discord for the graph. Sweet. Awesome. Well, guys, thank you. I think so. I don't see any particular questions from YouTube. I'm gonna check X real quick, and if there are no questions right now, it's fine. We'll just call it. If maybe some other questions arise later on, I'll ping you, Marcus, if you can answer them, or Simone or myself as well.
Absolutely. I'll be happy to help.
Sweet. Guys, thank you very much. I think this has been super cool. I'm looking forward to see what gets built with this, and I'm looking forward to I'm excited that this is finally live. We anticipated like a couple of months ago, so it happened. And thank you for your time, Marcus and Simone.
Amazing.
Yeah.
Thank you.
Thanks for having me, guys.
All right. See you soon.
Great.
Bye, everyone.
Bye-bye.